Okay, welcome back. And today we're going to do another example. And so in this example, we have two more curves. And again, you have to understand and recognize what kind of curves these are. So this is a function of a curve. This is a circle, okay? And it's 4 cosine theta, which will give you a circle along the x-axis, or starts at 0 along the y-axis and goes out this way. Okay, now a couple of things to realize about this too is as this traces from 0, so when is this equal to 0? This is equal to 0 at pi over 2, right? And at 3 pi over 2. Okay? So, when you go from 0, its cosine is 1, right? So it starts at 4 times 1, which is 4. And then as you go from 0 to 90 degrees, the curve traces, the radius goes from 4 to 0. And then as you go from pi over 2 to pi, now this becomes negative and goes from 0 to -4, or to -1. And so the radius in this area here, the radius is flipping. So now it's tracing this curve. And so from pi over 2 to pi, it goes from 0 to -4. But again, the radius means that that's flipping across in this quadrant. So we're going from this quadrant down to this quadrant, okay? Now, and so what that means is what we're doing is from 0 to 2 pi, it's tracing this curve twice, okay? So that's one thing to keep in mind. And then, of course, this is just a circle of radius 2. Why? Because there's no theta, so it doesn't matter what theta is, right? This is independent of theta. So no matter what value of theta we have, the radius will always be 2. Okay, so that means it's going to be a circle centered at the origin, it's centered at the pole, and it's going to always from 0 all the way around to 2 pi, the radius is always going to be 2. Okay, and so we get a circle centered at the origin with a radius of 2. Okay, so we have these two circles that are overlapping each other, and we want the area inside this circle, which is the red one, and outside this circle, which is the purple one. So the shaded in region is the area we want. But the thing is we need to find the limits of integration. Okay, so let's do this. Now, let's set them equal to each other. So we get 4 cosine theta is equal to 2. So we're just taking these two functions, setting them equal together to find where they intersect, to find these two intersection points. And so we get cosine theta is equal to 1/2. And then so we see that cosine of theta is equal to 1/2 only when theta is equal to pi over 3 or 5 pi over 3. Okay, so again, we're restricting theta from 0 to 2 pi. Okay, but realize that from 0 to 2 pi, this is going to trace twice. So we've got to be careful because we don't want to count the area twice. Okay, so we want to go from here to here. Okay, so there's a couple ways we can do this. Okay, there's a few ways we could do this. We can go from 5 pi over 3 to pi over 3. Okay, and those are our limits of integration. Okay, so let's do that. So we can do a equals the integral from 5 pi over 3 to pi over 3. Okay. Now the thing is this will go to 2 pi, so it seems like it's going down. So you can split this up into 2 pieces. Okay? You could say, let's do the integral from 5 pi over 3 to 2 pi, right? And we could do the function, right? And then what we could do is then split it up into and add, then from 2 pi, which is the same as 0, you can go from 0 to pi over 3. So we can add them like that. Okay? So that's one way. Another way we could do it is we could say, okay, well, 5 pi over 3 is the same as negative pi over 3. So we could set up the integral to go from negative pi over 3 to positive pi over 3, and then put in our functions. That'll work too. So let's do that and see what we get. And then I'll show you another way that again is, I think, easier. That will also give you the same answer. But let me do it this way. Okay, so we're going to do 1/2. And now what are we going to do? We're going to take the difference of the 2 functions squared, right? Because that's what the formula is. So we're going to take 4 cosine theta squared minus 2 squared d theta. Okay, and so let's simplify this. This is going to be 1/2. We're going to go negative pi over 3 to pi over 3. And so this is going to become 16 cosine squared theta, right? Minus 4 d theta. And so here we've got the cosine squared theta. So again, we're going to have to use the identity. And so in this case here, it's going to be 1/2. And it's going to go from negative pi over 3 to pi over 3. And I'm going to factor out a 4. So that's going to make this into 4/2 times 4 cosine squared theta minus 1 d theta. Okay? Now, at this point, let's put in the identity. So this is going to be 2. So this is going to equal 2 times the integral from negative pi over 3 to pi over 3. And so this is going to become 4 times, this is going to become 1/2 times 1 plus cosine 2 theta minus 1. d theta, right? And so what is this going to become? This is going to become 2, the integral from negative pi over 3 to pi over 3. And then I'm going to distribute and simplify. So this is going to become 2 plus 2 cosine 2 theta minus 1 d theta. And so now, this is just going to become what? It's going to become 2 times the integral of negative pi over 3 to pi over 3. And this is going to become 2 cosine 2 theta plus 1 d theta. Okay? And now I'm just going to integrate. So this becomes what? 2 times what? This is going to become, well, the antiderivative of cosine is sine. So this is just going to become sine 2 theta plus theta evaluated from negative pi over 3 to pi over 3. Right? So again, all I did was divide by the derivative of the inside here to get rid of the 2. And the antiderivative of cosine is sine. Okay, and so that's what I get for here. And then this becomes theta. And so now if I evaluate it at both, now here I'm going to get what? 2 times, I'm going to get sine of what? 2 pi over 3. Okay? So 2 pi over 3 plus pi over 3 minus sine of negative 2 pi over 3 minus pi over 3, right? And so now what do I get? Now this becomes what? 2 times, I get, well, what's the sine of 2 pi over 3? Okay, well, so this is going to be 2 pi over 3 is going to be a 60-degree angle in the second quadrant. So sine is going to be opposite of 60 degrees, which is going to be the square root of 3 over 2. And it's going to be positive. So square root of 3 over 2 plus pi over 3. Okay, minus this. Okay, so let's do this. So we're going to do minus, and then this is going to be, well, this is equal to, well, now the sine of negative 2 pi over 3 is the same as negative sine of 2 pi over 3. So this is going to be negative sine of 2 pi over 3. So guess what? Well, the sine of 2 pi over 3 is square root of 3 over 2. So now this is negative. Okay, let's do it a different way. Let's do it a different way. Hold on. making this more complicated. So negative 2 pi over 3. That's going to be in the fourth quadrant, or no, negative 2 pi over 3 is going to be in the third quadrant. Okay, which means in the third quadrant, I'm going to get what? It's going to be negative square root of 3 over 2. Right? So this is going to be negative square root of 3 over 2. But I can still, again, here's the thing, I'm going to get the same thing even if I use the property that sine of negative theta is equal to negative sine of theta. So again, you could use that too. You'll get the same thing. You still get negative 3 square root of 3 over 2 minus pi over 3. Okay? Okay, so now I'm going to simplify things. So this is going to be 2 times the quantity. This is going to be square root of 3 over 2 plus pi over 3 plus square root of 3 over 2 plus pi over 3. And so if I simplify things, what do I get? I get 2 times, this is going to give me the square root of 3 plus 2 pi over 3. And so this is going to end up giving me what? 2 times the square root of 3 plus 4 pi over 3. Okay, now that's what I got by doing that. Now there's another way I could do this and let's see if we get the same answer. I could just go from 0 to pi over 3, right? Because it's symmetric. Remember, see the symmetry? So this is symmetric with respect to the polar axis. So I could go ahead and take the area from 0 to pi over 3 and double it. So let's do that. See if we get the same thing. So let's go 0 to pi over 3. And we're going to go, again, we're going to say 4 cosine theta squared minus 2 squared d theta. And again, we'll just simplify this. So this is going to be 1/2. And so this is going to be 16 cosine squared theta minus 4 and so again I can pull out the 4 and this is going to be 4 cosine squared theta minus 1. Okay, and then this is going to be, hold on a second. I was going to take this and double it, right? If I'm going to take half, then I'm going to double it, right? So instead, it's going to be twice the 1/2. So this is actually going to cancel each other out, so it'll just be 1. Okay, so again, so since I'm doubling it, the half goes away, so 2 times a half is 1. And then I'm going to factor out the 4, right? And so I get 4, right? Now, if I integrate this thing, I get, well, actually, before I integrate, I'm going to substitute in. So this is going to be 4 times integral from 0 to pi over 3. And so this is going to be 4 times 1/2 times 1 plus cosine 2 theta minus 1 d theta, right? That's right. And then here I go. I'm going to 4. Now I'm going to integrate. So it's going to be 4 times Well, actually, no, I'm not going to integrate yet. Simplify. So 0 to pi over 3. And so this is going to end up being 2 plus 2 cosine 2 theta minus 1 d theta. And now here's where I'm going to simplify things. So this is going to end up being 2 cosine 2 theta plus 1. Right? So everything's the same that we did before. The only difference is I'm going from 0 to pi over 3 and I'm doubling it. So now the integral becomes 4, or once I integrate, it becomes 4 times sine 2 theta plus theta evaluated from 0 to pi over 3. And so now, what happens? I get, what does it equal? It equals, well, I'm going to get 4 times, and it's going to be sine of, well, pi over 3, so it's going to be 2 pi over 3, right? 2 pi over 3 plus pi over 3. Now at 0, now here's the thing, at 0, this is 0, and this is 0, so you just get 0, right? So if I just, so this is just going to be this minus 0, so I'm going to get 4 times what? Well, the sine of 2 pi over 3, well, 2 pi over 3 is where? That's going to be over here. So that's going to give me square root of 3 over 2 plus pi over 3, which is going to be, if I multiply through, gives me 2 times the square root of 3 plus 4 pi over 3, which is the same thing that I got before. So in this case, it's almost better to, sometimes it's easier to use symmetry and do it this way. Again, it's up to you. There's more than one way to solve these things. Take care. Have a great day.